Hello everyone, video 3 of module 7. In this video I will show you how to design concrete elements, that is including columns, beams and slabs and walls. So we set up the parameters for design in the last video. Also we defined reinforcement details for all concrete sections. So now all we need to do is just click on this button to start concrete design check. So there are two ways to do that. Either you can select a group of concrete elements and then press this button, just those concrete elements will be designed. Or when you don't select any element and just click this button, then all concrete elements will be designed. Now they are designed. So let's start from beams and see what we have in the menu and how we can use this feature in our design. So I'm zooming in. So those are concrete beams. It doesn't give you any color code, it just shows you the numbers because beams are being designed by SAP, but columns are being checked. So what the number means here, this information currently is for longitudinal reinforcing area based on Australian Standard version 2018. The number you see here is the area of the reinforcement you need at top and bottom of the beam at 3 locations. So at the beginning of the beam, mid span of the beam and end of the beam. So you see minimum reinforcement hasn't been specified here, it's just a design reinforcement. You remember we talked about the minimum ductility reinforcement. You can add the minimum reinforcement yourself to this, but this is just a design reinforcement. If I right click on this element, it shows me all combinations and the result of all of them. And generally it's highlight the critical one. So if I cancel again and again press, you see CombU G2 is the one that I have maximum top steel and also the bottom steel and shear steel. So I will explain you one by one. Let's have a look at the results. So if I come to the summary, this summary is based on Newton and millimeter. I can change here to kilonewton and meter. So it shows me the length of the beam. You need to check if you have any other element can reduce the unsupported length of the beam. You need to change the beam length here. And here it shows you the dimension of the beam, what's the depth, what's the width of the beam, and also other factors that you need to use for design. All of them are based on Australian Standard AS3600 2018. So you need to check the factors in your local standards and design parameters. Those are the strength reduction factor we use for design, and also here the results. So this is the negative moment and special moment if we have any special moment, and also what are the results for top and bottom. It gives you the reinforcement rebar and the moment rebar, and also here it gives you the design rebar and the shear capacity and the actual shear you have. So this is the shear capacity you have, this is the shear actually is in the analysis. That means you need steel. So you see that this is 5 ECU, that means the shear capacity of concrete, and this one is the shear capacity of the reinforcement proposed and designed by the software. So totally they come up with 155, which is pretty similar to this number. You see these numbers are very accurate. So SAP doesn't care about the actual size of reinforcement or reasonable space between bars. SAP gives you the ratio and you need to transfer this ratio to a reasonable size and space of reinforcement. I will explain you about shear very shortly. And then here it shows you the torsion. So you see the value coming from torsion, and if there is any longitudinal bar needs to be added or any shear bar needs to be added due to torsion, all of them will be calculated here. So this is the summary. Then if you need more detail, you can come to flexural detail. So in flexural detail, it's just showing you just whatever is related to the bending, and it shows you the numbers and parameters for bending. And you come here for shear detail, then you see just the part of design which is relevant to shear. So you can change this unit here if you want to see, or you can change this unit here before right clicking on any element, so you can have the values that is easy for you to read and understand. So I'm not going through the parameters and details because those are based on Australian standard, and you guys may use a different standard. So I'm just showing generally the principle. If you want to print of any of those, you can simply come here to file, and you can adjust your print setup and also page setup, page size, and then simply print it. So if you want to change some parameters based on the data that you have and you know is correct, and SAP doesn't pick it for some reason, which is pretty normal, you must be very conscious about that, you can come here into override, and here you see the factors that you can use for the design. For example, arm brace length or live load reduction factor, those, or framing type even. So you can actually change, even you can change the design section here from one section to another section and see if that section is enough. Sometimes the section is not strong enough and you want to see, okay, which section is okay, rather than doing the whole design again and unlocking the model and change this section. You can simply change the section here, and there is an option that you can keep this section as a chosen section, or it's just a trial section and SAP will keep the original section you have in the model. So if I come here and change it to 250 by 300 and then press OK, I mentioned which one is selected item. I just chose this one. You see many of items now are over stressed, so the ratio of reinforcement I have now, it's not acceptable for the small area of concrete I have. So you cannot accept all type of reinforcement ratio for beam and columns. That shows here clearly that what's happening. So this is the original section you had, but now you change it to 250, so it doesn't match. So you need to come here and again back to this and press OK, and see this back to the numbers you saw before. So let's see what we have in the menu here. So when we come here, we talk about view revise preferences, we talk about the design combo, view revise override. When you need to select on a structural element, then coming here and view revise override will be available. But this is pretty similar to what you saw when you right click on element and that overrides. So it's actually here. So they give you the same feature. Then the other thing you have is, this is the start design JX, the same icon. So this is just for do the design. This is interactive concrete frame design. If you want to use this, that means you can change the section and you can allow SAP to, when you're changing the section, SAP automatically get the result and get back to you. I personally don't use it and try to do it as the way I want, but sometimes it's useful if you want to check if you change any section what will happen. You can quickly check here. Display design info, what options we have here. So here we have longitudinal reinforcing that we discussed based on the square millimeter, which is the unit we have here. The other option we have is rebar percentage. It shows you the percentage of rebar that you have comparing to the area of the concrete, and you can figure out if this is over or it's acceptable. And the other option you have here is shear reinforcing, that you see that would be the same as the numbers we had in the element. So if we right click here, the shear is still coming here is for this specific load combination. When we check the bending, the shear here is not necessarily the maximum of the shear. You see you have more shear. And if you come to shear detail, you can see this the data, the number you have here is the ratio of the area of reinforcement divided by the space. So AV divided by S, which is the space, is this number. So that means the area of reinforcement divided by any space should be 0.99. For example, if the space of shear bars are 200 millimeter, the area of reinforcement you need at each 200 millimeter is 200 multiplied by 0.99, which is roughly 200 square millimeter. So you need, for example, 2 legs of N12 to give you area equal or more than 200, which is for N12 is something about 226 square millimeter for 2 legs. So that is okay. And for some areas you may need less. Generally it's not very practical if you play with the size of the shear bars, but it's okay if you play with the space between the shear bars or number of shear legs you have. You may have 4 shear legs here but just 2 shear legs here. That means 2 stirrups here but just 1 stirrup here. So you can play with those and see what is the economic and safe option for you. The other things we can see here after shear reinforcement is column PMM ratio. I will go through it for columns. This is not for beam. This is for beam column option mainly. It's good for columns. We don't have it here because we don't have too much axial load generally, so it doesn't show you anything. There are some criteria to using those. I will explain you later. The other options we have is the capacity ratio for column beam. The same again, this is for column beam capacity ratio. So this is joint shear, torsion reinforcing. So this is the torsional reinforcement you have, and you see it gives you 2 values. This is not top and bottom. This is the area of the longitudinal reinforcement you need due to torsion, and this is the ratio of the area of the shear bar to the space. So those values shall be added to the shear and longitudinal reinforcement you have. And let's see what else we have here after torsion. So you have identify PM failure. So this is for columns again, and identify shear failures and identify all failures. So if I come here and press OK, I need to zoom out and see if there is any element here or not. So what I can do, just to make it more clear, I can come here and put here not in view for areas and apply, and also I can go to 3D. So here is a mixture of steel and concrete. So what I can do, I can select all, and then I can come here and just deselect based on properties, easier material property, and I say any steel material property I don't want to see, and then again show selection only. Now I just have concrete elements, so it's easier for me to check. So here I can see all concrete elements, but I don't see any shear failure in the beams. So these red ones is generally for columns, and that could be for showing the color code for PMM ratio, not necessarily shear. So if I back to these and say identify all failures and press OK, gives me the same. So those columns are overstressed due to moment and bending. We will go through them. Those are the options generally you have here. So some of them may not be available because you don't have it in your design. So I'm coming here and go to column PMM interaction. So here you see it gives me the values. So I can go to elevation, which just make it more clear. So here you can see the vertical concrete elements, the stress ratio. So you see some columns are overstressed, but piles are okay. So let's have a look at the piles, and then we will get back to columns. So if I come here and for example right click on this element, it gives me the pile, what's the information and what is the critical section for stress. So if I come to the summary, I can see here the length of the pile is chosen 4000. Is that correct? Probably not, because piles are confined by a spring. If they are in a loose sand, yet that's okay, but if they are in the rock, then you can reduce this length. And even for loose sand, it's not fully unsupported, so you can justify the unsupported length based on the stiffness of the sword. You may end up with 2 meters or 1.5 meters or anything like that. That could be mainly based on your engineering judgment. I wouldn't say there is a specific formula to reduce the length of the pile when it's confined in the rock or sand, but based on the stiffness you can make decision. Here changing these values to kilonewton meter. So you see here is the summary of the capacity for the axial load and for the moments. So those are the design, and the capacity is defined this ratio. And then here we have the axial force and the factors we have here. So sometimes you need to play with these factors. As I say, you may change the K factor, you may change the length factor and make it correct. We have definitely this option in our steel design. I will talk about that for you. The principle would be the same. Here you see the shear values and also the capacity, and based on that you can see that what's the result and what's the design rebar that end up with this. The shear capacity designed by SAP is actual values. As I said, it's not really the logical number of bars or a space between bars. And then you can see here the joint shear design is not calculated, and also the beam column capacity not calculated. So here is mentioned that is not needed, not calculated, or not applicable. And then here you see overstrength factor and some other factors that really want to design based on AS3600. Again, you can come here and adjust and make a print. So the flexural details and shear details are just specifically showing part of that summary, maybe adding more details about flexure. So you can check which one is required for you. You can go to tabular data, and here is show you what's been checked for this column, for which load combination at which location of that column. Up to every 500 millimeter this column is checked. What is the PMM ratio and what is the shear ratio? All of them are listed here for all load combinations, design load combination that you specify. So if you need any full summary of design of any elements, you can find them here. Then what we have here is interaction for the columns. So when you come here, you see the interaction based on having phi or no phi, and also no phi with Fy increase. And here it gives you the options that axial force with moment in 3-3, so M3, or axial with M2, or just MM, or 3D. And here you can move and rotate this angle you see. So this is how you can check anything you want, and it gives you the interaction graph. And I'll talk about all of them. So this is for pile. Let's see what's happening here. If I right click on this column is overstressed. The capacity ratio is 1.4. That means design load divided by the capacity is 1.4. That means it's about 40% overstress. Some softwares give you the capacity utilization ratio that is different. So capacity utilization ratio means the ratio of the capacity to the load, but here is ratio of the load to the capacity. So you must be mindful what software is talking to you about the way of presentation, and use it properly. So if I come to the summary, here I can see that this column is 400 by 400, and here is the capacity ratio 1.25, and it gives me all information about the critical load combination. Live load reduction factor is 1, and here what's the moments, and in 2 or 3 direction what's the minimum design moment, is it more than that or not, and also what's the other factor for design. So the length factor is 4, the K factor is 1. So is that correct or not? You need to justify. We have a wall system here, so K factor 1 is correct. We don't have anything between these columns, so length factor 4 is correct. If you have any element here that is not shown and you know that the length of column is limited, you need to choose. Sometimes in one direction column has the full length, in the other direction column may have half of the length or portion of the length. You can play with that. I will show you in steel design because we definitely need it. Here I'm not playing with this size of columns or changing this number of bars. You can do that and you just see if add the size of, for example, column, or add the number of reinforcement, or increase the size of reinforcement, will end up with a better result. If you have any issue with regards to that, please contact me and email me and I will explain you in more detail. So those are basically the information for the design of vertical and horizontal frame elements. And here there are 2 other things that I would like to share before move on. One is the joint shear, that shows you where the joint shear stress ratio is determined for which station, and mention the conditions here that may be varied based on the type of standard, so please check your local standard. So when they checking the joint shear stress, and also when they checking beam column capacity ratio, in these conditions the software will do that. So you can check if you want to have this checking your design for any reason, depends on the value of moment and axial forces.